All right, on our second day of factoring, we're learning something new, and this is something you haven't done before, but it falls into the category of after you factor out your greatest common factor, if you have two terms, and it's a sum or difference of cubes. So in other words, instead of we did a difference of squares, which was a squared minus b squared. This is a sum or difference of cubes, so it's a cubed plus b cubed, or it's a cubed minus b cubed. And there's a pattern for that you have to memorize or know to go by the pattern when you're doing this. Now, like I told you, so this is one of those things you need to learn or refer to your factoring flowchart when you're faced with how to do these type of problems. So a sum or difference of cubes, you have a cubed plus b cubed, or the exponent can be some multiple of 3 in order to take a cube root of it. Okay? So we're going to start first with x cubed minus 8. Well, first of all, you notice we still have that a plus b, a minus b, that we have to figure out what a and b are. Well, first of all, then, what I want you to know is that A is the cube root, and that's a 3, of A cubed, and B is the cube root of B cubed. So in other words, if I start with the cube root of, in this case, my problem, it's x cubed. And if we've done these, we've simplified with these different indexes other than square root. So the sum of the cube root, the cube root of x cubed then is just x. And if 8 is 2 cubed, then remember the cube root of 2 cubed. If these match these numbers, your answer is your base. So the cube root of 8, or 2 cubed, is 2. So that's our A and B. And we're going to follow this pattern. And we have a difference because we have a minus sign. So we're going to use this pattern right here. All right, so here we have our x cubed minus 8, or, in other words, if we wrote that with that would be the same as x cubed minus 2 cubed. Okay, so we're going to fill in those blanks. So I'm going to write it here, and I'm going to write this as x cubed, just like I did, minus 2 cubed. So that's your A and B, your x and your 2. So our pattern says our first parentheses are A minus B. So that's going to be, parentheses, x minus 2. Then we have 3 things in the second set of parentheses. The first one is A squared. So that's x squared. Then we have plus. It's the opposite sign of what's in your problem. Okay. And A times B is 2 times x, or 2x. And then this last sign in this trinomial is always a plus. And that's B squared, which is 2 squared. But I'm not going to leave it like that because I'm going to multiply that out. So your final answer is going to be x minus 2, and then it's going to be x squared plus 2x plus 4. And that will be your final answer. And this last trinomial, you cannot factor anymore, so there's no use really trying. This is the pattern that it stays in when you factor it. Now, how do you check it? If you want to check, the way you check every one of these things is you multiply them back out to see if you get to your original problem. So let's go ahead and check this first one. Probably not going to check every single one of them, but we'll check the first one. So the first thing we're going to do is take this x, and we're going to multiply it by each one of the three things in that second set of parentheses. So x times x squared is x cubed. Then we have plus x times 2x is 2x squared. And then x times 4 is plus 4x. Now we're going to multiply this, the minus 2, by everything in that second set of parentheses. So you have minus 2x squared minus 4x and minus 8. When I multiply that 2 by all those things. Now let's look. We've got a positive 2x squared here, and we've got a negative 2x squared here. Those are going to add to be 0. Then you've got a plus 4x and a minus 4x that also will add to be 0. And so what are you left with? You're left with x cubed minus 8, which is your original problem. So that was a correct factorization as a difference of cubes. And so with these, just like with the difference of squares, you just have to follow the pattern. And the only really hard part is to identify what A is and what B is, and to remember that you always have to factor out the greatest common factor as your first step, if there is one. So let's go on to our next two examples. We've got, next example. Now this time, we've got a greatest common factor. And the greatest common factor in this case happens to be a 2. So we're going to divide both of these things by 2. And we also have a plus sign, so instead of a difference of cubes, we have a sum of cubes. So let's first factor out our 2. So we have a 2, and then you're going to have 27 x cubed plus 64 y cubed. Okay. So can we take the cube root of each of those? We couldn't to start with, the 54 and the 128. But if you remember, 27 is 3 cubed. So that's the same as 3 cubed x cubed. And 64 is 4 cubed y cubed. So when we think of this, as we put it in our pattern, we've got the a cubed, okay, and we've got plus b cubed. And if you go back to the first page, if you need to, or if you have your factoring flow charts, you can see that factorization is a plus b. And then you're going to have a squared minus ab, again, the opposite sign for that first one, and the second one is always plus for b squared. Okay? All right, so what is a? Let's just identify them. A, in this case, is going to be 3x, and b is going to be 4y. It's the cube root of each of those things that are a cubed and b cubed. All right, so now we want to factor out. We're just going to do the part that's in parentheses right now. We're just going to do this part because that's the part that fits the pattern. That's this. Okay? So a plus b is going to be 3x plus 4y. And then a squared is going to be 3x, all of that squared, minus ab is 3x is a, and b is 4y. So that's our a times b, plus b squared is 4y, all of that squared. Okay, now remember I said we don't leave it. We're going to go ahead and multiply all those things out in that second set of parentheses. And also one thing we can't forget is we had all of this. We're factoring what's in green, but we still have that. So all that gives us is the 27x cubed plus the 64y cubed. We can't forget in our final answer when we write it about this 2 here in front. That's going to have to come down into our final answer. So the answer for the whole thing, so we're going to end up having to have a 2 here and a 2 here if we're going to write this final answer, okay? Because we can't leave that 2 out. We factored that out to start with. All right, so our final answer will be 2. And then you'll have the 3x plus the 4y. Now, 3x times 3x is going to be 9x squared minus 4 times 3 is 12, and you've got an x and a y, plus 4 times 4 is 16 y squared. And so that's going to be your final answer for this complete factorization for this sum of cubes. Okay, for this particular problem. Now, these are not always easy. This one was particularly hard, but I hope you can see what we did as we went through this problem. Let's go and we've got 8 examples in this set of problems. Let's look at the next 2. All right, now this, if you notice, that x to the 6th is a multiple of 3. And remember, when I take the cube root of something, I can divide it by 3. So let's look. We know that the cube root, let's just figure out what a and b are to start with. And you can go back and look at the pattern. But for this one, our a, or if I want to just write a cubed, that's 2 cubed, and it's x squared, all of that cubed. Okay, so does that give you x to the 6th? Hopefully you realize, remember, parentheses to a power, you multiply them. So from that, then, we know that a is equal to 2x squared, because those are the 2 things that are cubed to get a. Then b cubed is the same as 5 cubed. 125 is 5 cubed. So in this case, b is just 5. So what's different with this one is that we had that multiple of 3 is our power. But that's also can be cubed, and so you have to realize how to do that. Now we're going to find our pattern. It's a difference. So the pattern is a minus b, and then it's a squared plus ab plus b squared. So a minus b is going to be 2x squared minus 5 I didn't factor anything out, so I don't have another number in front. Then a is 2x squared, and all of that is squared, plus a again is 2x squared, and b is 5. That's your a times b, plus 5 squared. Okay, so your final answer is 2x squared minus 5 times 4x to the 4th power plus 10x squared. You multiply those things out, and then plus 25. And you're done with that problem. Okay? Now, looking at number 4, there is a greatest common factor here. Our greatest common factor is a 5. It looks like it could be a sum of cubes, but let's be sure. Right now I can't take the cube root of 15, and I can't take the cube root of 5. So let's divide it by a greatest common factor, and I get 5. Remember, you have to put that in front. And then I have 3x cubed plus 1. And I can't do any more with that, because I can't take a nice even cube root of 3. Remember, taking a cube root is not the same as dividing by 3. It would have to be some number times itself 3 times. And there's nothing that will do that and give me a 3. 1 cubed is 1, 2 cubed is 8. There's nothing between that I can take the cube root of. So this is as far as I can go with this problem. That's your answer. Now let's look at 5. Now on this one, we've got a multiple of 2 for an exponent. So that leads me to think that this might be a difference of squares. Okay, so let's go back and talk about this. That's kind of like having that x to the 6th. 6 is divisible by 3. 4 is divisible by 2. So when you see a multiple of 2, it's possible that it's a difference of squares. So remember, the factorization for a difference of squares is a squared minus b squared is equal to a minus b times a plus b. Okay? All right, so do we have that? Well, what is the square root of x to the 4th power? That would be your a value. And in this case, that would be x squared. And b would be the square root of 81, which is 9. So this one will factor as x squared minus 9 times x squared plus 9. But then you have to look again. Since I have 2x squared terms, can I factor again as a difference of squares? And so you look at the factor that has the minus sign, and yes, this is also a difference of squares, so it will factor more as x minus 3, x plus 3, and then you have x squared plus 9 that you can't do any more with. Okay, so then that's your final answer for this problem. Okay. Now for 6, we have a greatest common factor of 3. So I'm going to factor out a 3. Okay? Which means you have 3 times x to the 4th minus y to the 4th when you divide it. Now, remember, the square root of those are going to be x squared and y squared. So that's a difference of squares that will factor as x squared minus y squared times x squared plus y squared. But then this first one is a difference of squares that will factor as x minus y times x plus y. And then we still have the x squared plus y squared. And that will be the final answer, the final factorization for that one. So with these, if you have a higher power than x squared that you can factor as a difference of squares, you have to keep looking at it. Remember that last thing on the factoring flow chart is check to see if you can factor anything anymore. And in this case, yes, both of these cases, you could go ahead and factor again as another difference of squares. So let's look at the last two that we've got. Okay, so there's a greatest common factor in 7. The greatest common factor looks like it's going to be 16x squared. So when you divide it, you're going to write your 16x squared in front. And the 16s cancel here, and x to the 4th divided by x squared is x squared. Here the x squareds cancel, and 32 divided by 16 is 2. Well, I can't take a square root of 2, so that's as much as you can do. It's not a difference of squares. That's your complete factorization. I can't go any more because I can't take it would have to be x squared minus 4 or 1 or something I could take a square root of to be able to factor that as a difference of squares. And the last one, this is a difference of squares because I can take the square root of x to the 4th and the square root of 49. So that's going to be x squared minus 7 and x squared plus 7. But in this case, again, I can't go another step and factor it again as a difference of squares like I did in those last two problems on the other page because I can't take the square root of 7. So this is your final answer. So sometimes you can go farther and keep factoring more, and sometimes you have to stop, and you have to know, your square roots and your multiplication tables well enough to be able to decide if you can go farther or if you're done. Okay, those are some examples to help you with your homework.